This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 2.5, and today we're going to be talking about transformations. By the end of this lesson, you will be able to, when given the graph of a function, graph its transformation under certain translations, reflections, stretchings, and shrinkings. Okay, so there are some functions that you should be able to recognize upon viewing. Okay, and we're going to go through a bunch of those right now. First one is our basic identity function, and that's a basic linear function. We also call these functions parent functions. These are functions that haven't had anything added, subtracted, or multiplied to them. They're about as simple as you could possibly get. Okay, so this first one is your identity function. Next one is your squaring function. You know this as a quadratic, right? This is our parabola. So our parent function would be a basic x squared. Square root function. They all take this general form, whether or not they've been moved around. This is, again, our parent function, starts at the origin. Cubing function kind of looks like this funky sideways extended S. So any cubic function will have this general form. Cube root function. So again, this is very similar to the square root function, except it has different values in different locations. Reciprocal function. Okay, a hyperbola, right? This is a division. So this is our reciprocal function. Absolute value, of course, we know looks like a V. Okay, so now what we're going to do is we're going to take those pair of functions and we're going to start working with them. We're going to start talking about vertical and horizontal translation. Okay, so say we have some function f of x, and we're going to look at what happens when we create new functions by adding or subtracting to that function for values that are greater than 0. So here's our first one. Now, I have my function 1/5 x times 4. This is my blue function, right? My blue function here. So what would happen if I took that function and I added 5 to the entire function? So what it looks like has happened is my function has shifted up vertically 5 units. Okay. So describe the translation on the page prior. Make a conjecture about the rule for the translation. So essentially what we have done is we have taken f of x and we've added to it b. Okay, so explain to me what seems to have happened. Okay, so again, we're adding it to my function. What has happened to it? Okay, whoops. Okay, so we're going originally from here and we're shifting up. So explain that in your own words. Okay, so this next one, I've got my function 1/5 x to the 4th. And this time I'm subtracting 3. So if I subtract b, some value of b such that it's greater than 0, what happens to my function? So again, describe the translation and make a conjecture about the rule for the translation. So what do you think that general rule is? Okay, so hopefully this is what we kind of determined. When we're dealing with vertical translations for when that value of b is greater than 0, the graph of y equals f of x plus b is the graph of y equals f of x shifted up b units. So if we add to f of x, it shifts my function up that many units. If I subtract from f of x, it's going to shift my graph down that many units. So hopefully you were it was very easy for you guys to come up with that conjecture. Okay, so what about if we're talking horizontal translations? My original one is 1/5 x to the 4th. Okay, my green function. My yellow function is 1/5 times the quantity x minus 3 to the 4th. So notice where I'm taking 3 away. Okay, notice where that minus 3 sits in my f of x in my equation. Okay? So minus 3, and we seem to have shifted to the right 3 units. Okay, from green to yellow, 1, 2, 3. We seem to have gone 3 units to the right. So describe the translation on the page prior and make a conjecture about the rule for the translation. Remember, conjecture is just a fancy way of saying guess what's going on. Okay? Make an educated decision or an educated guess on how this is affecting. Okay, so my next graph, I've got 1/5 x to the 4th. Again, that's my original. And this time I'm adding 7 specifically to the x value. Okay, 1/5 times x plus 7 raised to the 4th. And this time we seem to be moving 7 units to the left. Okay, so from our original, we've moved 7 units to the left. And that connection being that adding 7 to the x value. So describe the translation on the page prior and make a conjecture about the rule for the translation. Okay, so hopefully you've come up with this rule for our horizontal translation for when d is greater than 0. The graph of y equals f of x minus d is the graph of f of y equals f of x shifted d units to the right. So if we subtract d directly from x, we move to the right. And in the same note, if we add d directly to x, we move d units to the left. Okay? So add brings you to the left, subtract brings you to the right when it's taken directly from or given to that value of x. Okay, so describe how each graph can be obtained from the parent function. Remember, parent function is that original function that hasn't been touched, okay? Graph the function to verify your hypothesis. So our parent function, we'll call it f of x, would be x squared. Okay, that's our squaring function, right? So, describe how each graph can be obtained from the parent function. So we're going to talk about this in terms of words, okay? How is x squared minus 6 different from x squared? And I want you to think about it without graphing it and looking at it. Okay, so we talked about when we added or subtracted from f of x, that being a vertical translation. And when we subtracted, we went down. And in this case, it would be 6 units. Okay, so we had a vertical translation, and we went down 6 units. Okay, now to verify this, we have our original function x squared. And then we have our x squared minus 6. Now hopefully I was right. Whoops, sorry about that. Hopefully I was right. Hopefully my graph is going to vertically translate down 6 units, and it does. Okay, so you're going to do this in words first, and then you're going to explain and prove yourself graphically. So describe how each graph can be obtained from the parent function. Graph the function to verify your hypothesis. Now in this case, our parent function would be f of x equals the absolute value of x, right? That's our parent function. Now notice that we're subtracting 4 directly from the x. We're not subtracting it on the outside to the entire g of x. We're subtracting it from the x specifically. So that tells us that this is a horizontal translation. Okay. And since we're subtracting, if we go back and remember our rules, subtracting means that we are going to the right. And in this case, we were talking 4 units. Okay. And we're going to check ourselves here. We've got the absolute value of x, which is our parent function. Control G brings back up that function bar. And then we had the absolute value of x minus 4. And we seem to have moved to the right 4 units, so we're good. Okay, the next one, square root of x plus 2. And again, we should know what our parent function was. Our parent function would have been f of x equals the square root of x. Okay. And again, it looks like we're adding it directly to that value of x. So this is going to be another horizontal translation. Okay. And since we're adding, we're going to be going left. And in this case, 2 units. Okay. So let's check ourselves. Square root of x. There's my square root function. And we're thinking going to the left 2 units, so hopefully we were right. Square root of x plus 2. And we have gone from here to here, so to the left 2 units, so we're good. Let's try one more of these. Describe how each graph can be obtained from the parent function. Graph the function to verify your hypothesis. Now, this one is unique because we have more than one translation going on here, okay? We are adding to the value of x directly, but we are also subtracting from the entire function h of x. All right, so we actually have 2. We have a horizontal translation. And that horizontal translation, because we're adding 2, is going to go left 2 units. And we also have a vertical translation. Because we're subtracting that 3 from the entire function, we can say down 3 units. I guess I don't need my u's to be capital. Okay. All right, so let's take a peek. My parent function, I'm going to insert a graphs page here. My parent function, again, would have been the square root of x. Okay. But what I've done to that is I've taken it, let's go one step at a time here. The first step was to add the 2. Okay, so this one, again, is going to move us left, right? Take my label and move it. But then on top of that, I then subtracted 3. So from here, I'm going to shift down 3 units. Okay? So that has more than one translation. And you'll see a lot of them like that. Okay. So let's talk about reflections. The graph y equals negative f of x is the reflection of the graph y equals f of x across the x-axis. Okay? The graph of y equals f of negative x is the reflection of the graph y equals f of x across the y-axis. So if it's negative f of x, it's a reflection over the x. F of negative x is a reflection over the y. If a point xy on the graph of y equals f of x, then y negative x is on the graph of y equals negative f of x, and negative y is on the graph of y equals f of negative x. Okay, so we're going to make this easier for you. Okay, we're going to take it apart piece by piece. Explain how g of x equals negative x cubed minus 4 times negative x squared can be obtained from f of x equals x cubed minus 4x squared. Graph to verify your response. Okay, so the first thing that we're going to notice is that f of negative x, right, f of negative x is negative x cubed minus 4 times negative x squared, right? So what that is g of x. Okay, so the way we got g of x was by finding f of negative x, by plugging that in. Because what we found was f of negative x, we can say that g is a reflection of the graph of x across the y-axis. Okay, reflection over the y-axis. And we know that because we plugged in that negative x. Okay, so by simply plugging in that negative x to see how we received g of x, we were able to determine that and to follow our basic rules. Now, of course, we can go in and check this graphically, which we're going to do. I wonder if I put a graph in there. I did. Okay, so we're going to put in f of x to start, not like that, x cubed minus 4x squared. So here's our original. And we're saying that it was a reflection over the y-axis. So let's see if that's in fact true for us graphically. So we've got negative x cubed minus 4 times negative x squared. Now all we did was plug in that negative, right? So what has happened here, and I'll move it up so it's easier to see, is this green looks like very well it was reflected over the y-axis. Here's my y-axis. Notice this has the same point. The yellow line and the green line share this point, 0, 0. Okay, and notice that's on the y-axis. So this is indeed a reflection over the y-axis. Explain how h of x equals 4x squared minus x cubed can be obtained from f of x equals x cubed minus 4x squared. Graph to verify your response. All right, so the first thing we're going to look at and we're going to pay attention to is that negative f of x, right, if I were to take my function f of x and multiply it by negative, that equals negative 1 times x cubed minus 4x squared, right? And that's just taking my f of x and multiplying both sides by negative. What this equals is negative x cubed plus 4x squared, okay, which we know is the same thing as h of x, okay, negative x cubed plus 4x squared, okay. So this would be a reflection over the x-axis. And of course, we can verify graphically. Graph our original function. Here's my original. And graph my reflection. And it has been reflected over the x-axis. Notice the points that it's sharing are directly on that x-axis. Okay? Now I'm going to stop here, and we're going to talk about vertical and horizontal stretching and shrinking in the next video. Okay? Thanks, guys.